Well, I'm going to say good afternoon, good evening to my students and all those that are taking advantage of these training sections. By the way of introductions, my name is Benedict Sarti Jr. I'm the founder of Voma Corporations and Voma Energy. That is our our PV or renewable energy sections of our corporations. I work alongside Mr. Augustus Command, my partner and um, manager of our institutions or our companies in. So today we're going to be diving into our training and we're going to be talking about system types, which is the fundamental for battery-based systems. We're going to be discussing battery-based systems. So the fundamental we're going to be discussing here, the fundamental of the training is going to be battery base. The reason why I decided to go directly into battery base because most of the PV systems built in countries like Liberia and other countries within Africa um, is battery based. Gray tie system or multi-mode systems are not very popular because of the inconsistencies of electricity or electric grid in our country. So that's one of the things. I'm going to share my screen. Um, all right, so let me go right into this first. System types. We use this material from the SEI, that's the Solar International, Solar Energy International. Materials used in this training is for training purpose, no commercial purpose, should not be duplicated or replemented. If found in such dubious art, you're going to be apprehended by law. This is for training purpose only, not for marketing purpose. So this course provides the basic concept and terminologies necessary to work with battery-based PV systems, including the purpose, applications, design, criteria required for different types of charging systems, batteries, and battery-based inverters. This course can be followed up with the design intensive course. So we got three other courses we're going to be doing, obviously. So let's move into your learning objectives. Well, objectives is that we recognize the demand and PV production curve. That's one of your objectives. Explain why energy storage is useful, one of the objectives of this course. Identify common types of PV systems and their major components. So if you have not done anything that relates to solar panel or solar system, the word PV stands for photovoltaic. So that's what the solar panel is called. So that's the right terminology or the right name. When you're speaking to someone who understands what it is, when you say PV, they know what you're talking about. If you use appropriate technology, every area, every occupation has appropriate technology that surrounds that occupation. That have doctors that are medicine terminologists, lawyer have legal terminologists, so there are different types. So we're going to be talking about the PV direct, the standalone system, standalone, the gray direct, the multi-move, and the hybrid. So these are five known PV systems around the world. We're going to describe charging options, talk about DC and AC coupling. Now let's talk about the system type. We got a low profile right here first. We have what we call the kilowatts, which is a kW and the kWh. kWh is kilowatts hour. Kilowatts and kilowatts hour, they're different. We'll dive into the different folder. Kilowatts hour are on a curve. So what is a kilowatts hour? Kilowatts hour is how many kilowatts a device uses or an appliance uses within an hour, within a period of time, or an hour, a minute, or a second. So that within an hour, so that's your kilowatts hour. Let's restrict it to hours. So we have in this curve here, this curve shows the residential demand curve of a specific family. So in developed countries, in the morning, everyone is home, people getting ready to go to work, the children's getting ready for school, 7 a.m. in the morning, a lot of appliances have been used. In the afternoon, everybody goes to work, kids are at school, more appliances are not being used. All these appliances are not using much current. In the evening, around 5 o'clock, people get home. The stove is on. The kids are watching television, or somebody is doing their homework on the computer. A lot of appliances have been used, and the demand is high. So we have high, low, and high demand. So that's the demand curve. What makes this important is if you have to design a PV system for a customer or an individual, it is important to understand the use, the behavior, the use, the daily behavior of a family. If people don't work, like in Liberia, more people sit home or they watch TV if they are current. So that means that they're going to be home a lot of time, and then that requires a lot of current, a lot of current. So it is important to understand the behavior or the usage when it comes to PV. Why is it important between the morning to afternoon hours? Because during this time, you have the sun peak. The sun is up. You're not using the battery. It's more like directly from the PV system. So if in Liberia people stay home a lot, in the day it's more important. Good time to do a lot. Good time to open the freezer a lot. Good times to play TV, listen to music, put a lot of appliances on when the sun is up. In the evening you can't do a lot because why? You're going to be using the battery of your system. The low profile is a power use of load. This could be a single item, or it could be the aggregate power use of many loads. For instance, all the electricity used in the house. Loads over time can be graphed into the demand curve, as shown on the slide. The height of the curve is power, so that is power, which is watts, and the blue on the curve is total energy consumption, watt hour. As shown on the slide. A typical resident pattern is high use in the morning, higher in the evening, and lower during the day when many people are at work and school. Just spoke about that. The demand curve shifts the time and level which corresponds to people or machines using power is influenced by a site, geographic location, type of electricity used. Some typical profile include the street light, dusk to dawn, residential, less demand during the day when few people are at home, commercial, business hours based load. So commercial, if you have a business, if you're designing for business, in the day people are at the office. So they will use the high consumptions. So you should know that if you were designing for a school, for example, when you're designing for a school, between the hour of 8 a.m. to 2 o'clock, let's say 5 o'clock, a lot of school activities goes on. So you know that they're going to be using a lot of electricity. Let me dive into this right here. All right. All right. Looking at for the slide, which is easy to see. Now, daily demand versus PV production. So as you can see right here, daily demand versus PV production. Daily demand versus PV production. Overlapping a PV production curve and a demand curve provides a good sense of how energy produced by a PV system will interact with the existing demand curve. The demand curve in this example may represent household demand during a typical week, in which a house is unoccupied during the middle of the day, while the residents are at work or school. In this case, demand peak in the morning and evening when the occupants are in the house, consume energy for cooking, lighting, entertainment, etc. So you can see right here, that's what they're showing. Energy usage excels PV production in the morning. Surplus of energy PV production excels energy usage in the afternoon. The sun is hot. lot of sun ray PV production meet energy usage. So over here, you have a lot of energy coming into the home. So say you have a refrigerator or other stuff, you want to cool your water and so this is a time to use that. If, if you have a water pump, you need to pump water into your reservoir. This is the time to actually take advantage of the sun, the surplus energy you're receiving from the sun. It's very important. That's what they're saying here. Very, very important. Because in the evening, energy uses excel PV production. Because in the evening, you have less PV production, but you have more energy to be used. So you're going to use, if you have a battery base, you're going to be using your battery a lot. So that's what it's saying right here, right? So that's what we're talking about right there. Common PV system types. So we're going to talk about the different types, common PV system type. We have gray direct, gray tie, utility, interactive. PV system that can sell electricity to the utility grid does not have energy storage. What is a gray tie? A gray tie utility interactive system. So for developed countries, a lot of countries in the Western world, when it comes to PV system, they have a gray tie system. What it means is that I put solar panel over my home. In the day, I have a lot of current being generated from the solar system. The meter that sends the grail from the utility company or LEC as you call it in Liberia begin to read backward. So I begin to so my energy now, my excess energy that I do not use in the afternoon goes back into the grill and I sell those energy back. In the evening when everybody comes home, that energy I use a lot of energy from the grill, not from my PV system, because at such a time the current, I mean the sun is down, I'm not receiving a lot. But that system does not have a storage, don't have battery. So they use in the night, they use LEC. You can set up a system like this in Liberia if you have LEC. Say you only want to use the LEC or the LEC current for night, in the night, and you use your PV system in the day. So when the sun is hot all day, you don't need much of a battery system. You don't even need a battery system with such a setup. The disadvantage is that on very rainy day or days that there is no sun, you're not going to have electricity in the day. That's a grid direct system. Then we have a standalone or off-grid. Standalone, what off-grid means you have nothing to do with utility. It's a standalone system. A PV system is not connected to the utility, which provide all power for the connecting load. Let me read a little bit. Standalone systems are not connected to the utility grid. So the standalone system is what we use, which is recommended for homes in Liberia. Because number one, there is inconsistency when it comes to the grid, the utility or LEC. There's inconsistency, it's not constant. So if I am paying $60 a month, I might as well just set up a system with a battery storage that in the night, when the sun goes down, the battery provides current or backup current for my home. That system is referred to as standalone system. All right, then we have multi-mode systems, are quite complex and can operate in both gray and interactive mode and standalone system. So we're going to talk about a multi-mode system. Multi-mode system is one of the most complex system. Say somebody has they have a generator and they have a LEC, so they can charge the battery with the generator if there is no sun. They can also charge the battery from the grill. They have what they call inverter charging. That will be able to charge, send current into your DC part of your system setup and charges your battery as well. So that kind of a setup is referred to as a multi-mode system. It's not very common in Africa and other countries around the world that don't have much of stable utilities setup. System configurations. This is a setup of what a system configuration is like. Sun send a ray to the PV array. See the blue, that's a PV, that's a PV array. From the PV array, we have your DC current that move to a DC load. So this right here is a DC load, an appliance that run on a direct current DC. The DC voltage of the load must be compatible with the foot of the DC power source. So what is that? This is only DC. You have nothing to do with inverter. So this system here, say for example, you have a farm, and in the day you want to be able to pump water into your reservoir to water your plants. You do not need to have an inverter to change that current into an AC. You can have a DC appliances so that way you do not need an inverter to invert or transform that current into an AC current, which is alternative current. You may not need that to be done. That now, let's move to feature and appliances application. So let me go to small here. PV direct systems have many useful appliances. One common appliance application for this system configuration is pump water in a remote location where the sun is shining. The PV direct system can be used to pump water into a tank or tub where it can be stored for later use. This simple addition of a float switch can turn the pump off when the tank or tube is full. So the system can be set automatically with what is called the float switch. So it's like your commode. The commode has a float switch. It has this thing like a little ball, like a little balloon. So as the water goes up on a resetting area, pop, it locks the valve so the water can come coming. So that's what a float switch looks like. Ventilation fan, such as an attic fan. So some people in other countries have fan in the attics. You know that how the homes in Africa can be very hot. So the people in developed country put a fan in the attics. When the fan in the attics is blowing, the big fan is blowing, it cools the attics, keep cool your ceiling. So that reduces the ratio of heat that comes into the home. That's a smart move. It will reduce the use of a lot of air conditioning if you have an attic fan. That's what they're saying. Because of the simplicity of PV direct system, they require very few additional components and maintenance compared to a more complex system configurations. However, it is important that the PV array and the load are sized to operate together. In PV direct system, there is no components to regulate the PV array because the voltage is not normally regulated from the PV array in this type of system. The DC load must match the voltage characteristics of the PV array. In the voltage of the array, if the voltage of the array is too high or too low as compared to the required to the compared to that required by the load, it could cause damage over time. In addition to matching the voltage, there must also be significant current available from the PV model to the array for the load. So what they're saying here is, if I have a water pump, I can't take a PV system that is going to be producing higher voltage than that water pump. If the water pump is a 12-volt water pump, and I have a PV system, a 12-volt PV system, I must regulate, make sure that the load is compatible with the PV system that is installed. Very important. If not, the current is too excess of current is going to damage either the motor for the water pump or it will damage my PV array. That's what it's saying right there. So to move forward. System configurations. So DC load, an application that runs on direct current DC. The DC voltage of the load must be compatible with the voltage of the power source. This is exactly what I just explained to you. So I'm gonna go. So that is the end of my first section on this. And, back to my slideshow. right here. PV system that is not connected to the utility grid is called a standalone system. PV system also commonly called off-grid. So PV system are commonly called off-grid system. All right. So DC standalone system. So the system diagram in this slide only operates DC load, but the term standalone can be used to describe a wide range of systems, including those with a AC load. Standalone systems often include a battery or a battery bank, multiple batteries connected together to store energy for time when the PV array cannot produce enough energy to meet the required load, for example, during the night or during cloudy days. Note, the term batteries and energy storage are frequently used interchangeably, although they are some although there are some form of energy storage that are not considered batteries, like flat wheels and reservoirs. However, in this course, both will be used to refer to chemical storage of electrical energy. Batteries are an expensive part of a system. It is important to protect them with a charge controller. A charge controller monitors battery voltage and regulates the PV array power as needed to keep the battery from becoming overcharged. Some charge controllers have more sophisticated control of battery charging, regulating the charging voltage and charging current as the state of charge of the battery changes. When the sun is shining, the array produces electricity. This energy passes through the charge controller and is stored in the battery. Current will also pass through the loads if they are drawing power. As the battery begins to reach a full state of charge, most charge controller will reduce the charge current coming from the PV to the battery bank. Okay, let me explain to the finish battery bank. When the batteries are fully charged, the charge controller will disconnect so no charge current is flowing into the batteries to prevent the battery from being overcharged when the sun is not shining. The battery provides the energy to operate the motor. This is very important. Standalone system. You have a standalone system. Say, for example, I'm designing a system for a gentleman in Liberia. All right. He has, his total load is almost around 11,000 kilowatts hour a day. That is his total load, including all the appliances he has. A day, he needs about 11,000 kilowatts hour of electricity to run his appliances. Now, the system build is being developed. You're going to have a battery bank. In the evening, when there is no sunlight, no energy from the sun, or there's cloudy days, he's going to depend on his battery to supply current to all of his appliances. Now, the battery need to be regulated by a charge controller. The charge controller regulates how much of energy goes into the battery. Because when your PV sends energy, DC energy into your battery, if the battery gets charged fully, if there is no charge controller, the battery will keep being charged. It's like your your commode. You flush the commode, the water start pumping up. Boom, water going up. When it reaches certain level, the bulbs pop, the rest of the valve locks. So the charge controller serves in that capacity to stop the intake of charge into the battery. It's a very important component that is needed when you are setting up a battery-based system. The difference between a battery-based system or a standalone system and a grill system, you may not need you do not need a charge controller because you don't have no battery bank. Your utility, your energy is going directly into or into the house or into your AC, your inverter, changing it into AC, and then selling the excess current back to the utility grill. In the night, it's spin the other way around. You have less current coming in from the PV array. You have more current coming from the utility. That is different. A battery-based system, which is a standalone system, in the day you use more of your energy from the sun ray. The battery stores, waiting. When the sun goes down, the battery kick up. It begins to supply electricity to your appliances. Okay, it's very expensive. That is why I always say to my customer, I know you have all of these appliances here. What is important to you? What is important to you? Because if you have a big your daily kilowatts hour is too much, and you have a small battery space system, small battery system, it won't be able to supply the needed amperage for your appliances. Because PV array is the only charge source in this specific configuration of a standalone system, there is a limited amount of energy available. Often the battery will be sized to store electricity to run the load for a certain number of days. And the PV array will be sized to recharge the battery based on the size of the load and other factors. This is self-explanatory. So when you're building a system, maybe you sell a battery for 1 day that the battery can run for an entire day, can handle your appliances for an entire day when there is no electricity, no current from the grid. Can be multiple days. If so, then you're going to need other charging sources. And that system have to be changed into a multi-mode system where you're going to have either charge coming from the utility or from a generator. But if you just for a day when there is no current, no light, or no source from the PV array, then you're going to need your battery can only run for the day, or depending on how much of a battery base you have, how much days the person want the appliances to run without any source of electricity from the PV array, then requires more batteries. The person say, oh, for the 2 days, I may be running my appliances without no PV array because it's too much of rain, there's no sun. Then you're gonna build a system that can have excess storage of electricity to handle the load for 2 days. Or you have a standby generator that can run in a multi-mode system to charge the battery on cloudy days. Cloudy days. Very important. Cloudy days. Okay? So this is a diagram that shows right here. I'm gonna put it a bigger diagram. So this is a diagram that shows right here. The sun shines on your PV array. The charge controller integrates the local control. The charge controller with the integrated load controller right here charges the battery. Then it goes into your DC. So you can have a DC setup like this. This here, there's no inverter directly into DC. That's one setup right there. AC standalone system. So this is an AC standalone system. What it means is that your current is going to be inverted or changed into an AC current. PV array, your charge controller charges your battery. The current goes from your battery onto your inverter when there is no sun or no energy from the PV array, or it goes directly during the time or in the day when you're getting enough energy from your PV array. That's what the arrow here shows. So you have energy coming to the battery get charged, battery supplies your inverter during the time that you have no energy coming from the PV array. That's what it shows. And then that goes inverter, invert the current into an AC, goes into your AC survey panel, and from the survey panel, it goes into your sockets where you plug in your appliances, your AC appliances like your television, refrigerator. There are DC appliances. I was told that they have DC light bulbs in Liberia, and now they're coming up with DC appliances. So when you have DC appliances, it made it easier because you use less of electricity. AC often has higher voltage. So, but AC is the most available appliances on the market now. It's just developing DC appliances. It's very expensive, hard to maintain. So that's what that is showing. I want to go to the feature of a standalone system. Now, standalone feature, not connected to the utility grid, energy storage allows load to be used at any time. Don't have to match load to the output of the energy source. Energy limited by the PV array and battery bank size. AC power limit by the inverter. Power output does not fluctuate with irradiance. Options of having DC to AC load on both can be multiple can be compatible with standard AC electricity wiring and load. Now let's read. The standalone PV systems are characterized by being independent systems that are not connected to the utility and may have energy storage, typically in the form of a battery. So load can be powered by power, power both day and night. Because this type of system is not connected to the utility grid, they are limited to the amount of electricity they can produce and store. To operate effectively, AC and DC load must be carefully examined so that the required amount of electricity produced productions and energy storage can be properly sized. This will be discussed in later lessons. Improperly sizing standalone systems will lead to poor performance, reduced battery life, and can damage components, all of which can result in unhappy end users. So sometimes you design a system for a customer, the customer don't know is not very transparent with how much of the appliances they're going to be using. You set up a system for them, and at the end of the day, they start adding. I was told they start adding to their adding loads, and then the battery can handle things. The battery is being overused. Um, Battery lifespan is short. The customer is unhappy. And then they'll complain, and now you have bad referrals. People get to say, "Oh, they want to do the job. It doesn't work well." So it's very important to take into consideration the system size when it comes to standalone system. Unlike the PV Direct system, there is no concern about matching the load with the instantaneous output of the PV array when there is energy storage in the standalone system. Since battery output does not fluctuate considerably as the output of a PV array does, this allows a much wider range of loads to be connected to the system. So you heard that unlike PV Direct system. So that's what they're showing you. Standalone system can operate DC load, or if a battery-based inverter is used, the system can also include an AC load. One advantage of the AC standalone system, which includes a battery-based inverter, is that standalone electrical equipment and appliances can be used in the system. So that's what I said. You have the DC part of your system set up, and you have the AC part, which you have your inverter change, your AC, handle your AC appliances in your home. This is a picture here of standalone applications, telecommunications. This is a standalone telecommunication in developed countries. They have the telecommunication pole, and they have PV systems, street lights, parking meters, weather stations, railroad. Those are all most of them which use standalone systems. There are countless applications for standalone systems. A few examples of DC standalone systems are road signs, street lamps, land cap, lightings, and telecommunication systems. The material will be given for you guys to read by yourself as well. Now, standalone system with a backup generator. And we're moving back into something more, a little more complex. Standalone system with a backup generator. Now, this right here has a backup generator, so you need something called an inverter charger. This is a recommended system for most homes in Liberia. Very recommended. Some people have a little generator there. So what it does is that you can put on your generator on a cloudy day. As you're running your generator, while your generator is supplying current into your home, the generator is also helping to charge your battery. But you're going to need an inverter charger. Inverter charger sends DC current to your batteries to your DC side to charge your battery, and it has AC current going into your AC service panel to run your appliances. So while your appliances are on, it also sends current into the DC part of your system to charge your battery. So you can have that system set up. Read about it. Backup energy sources are an important consideration with standalone systems, PV or hybrid, to help keep the battery charged when there is not enough sunshine. These additional charging sources minimizes the chances that the user will run out of electricity, even during extreme weather conditions, and minimize the chance of an LVD, shorting off. Depending on the system design, the use of a backup energy source may be inadequate, may be infrequent. So depending on the system design. So if you design your system to handle at least a day of usage of electricity provided by your battery in a very rainy day or very cloudy day, you may still be able to run your appliances for a day. But depending on that, some people will frequently need to have the generator run. Depends. That's what I'm saying. If you have a very less, but small battery, you have a system, your batteries, you're running your battery all your life in your battery, you may likely need a generator as a backup to charge your system and run electricity and run your appliances as well. Some is now. But backup uh, infrequent. But backup is quite critical if power outage or are undesired. Can also increase battery life by ensuring they are not too deeply discharged and are fully recharged on a regular basis. Some inverter for battery-based system are inverter charger, meaning that they not only invert energy from DC to AC, but they can also convert AC to DC. This is useful for charging battery from an AC energy source, like a generator or the utility grid. One limitation is that the inverter can only operate in one of the mode at a time. That's what they're saying, one of the mode at a time, inverter or charge, but not both at the same time. However, when in charge mode, may invert and charge, will charge the battery and pass through AC power from the generator to the load. However, when in charger mode, may invert slash charges will charge the battery and pass through AC power from the generator to the load. In many cases, a PV slash generator hybrid system has this is called a hybrid generator hybrid system has PV as the primary charging source for the battery bank with a generator that can be turned on manually or automatically to fill in the time where the PV system is able to keep up with the load and keep the battery charged. It is common to use a fossil fuel generator running on gasoline, diesel, or propane as a backup source. So that's self-explanatory. Let's talk about the devices. Hybrid PV system. Multiple sources of generations allow for complete complementary source and backup. More complex system design and installation, increased maintenance. Application, remote area power system, off-grid home and cabin. Can be grid connected or standalone. An obvious benefit of hybrid system is that there are multiple charging sources for the battery. The charging sources are usually designed to complement each other and take advantage of more than one renewable energy resources that is available at the site. Renewable energy at the site. Generators are commonly used in conjunction with PV if other sources are not available or sufficient. With multiple charging sources, there is a much greater chance that the load will operate uninterrupted and that the battery will remain healthy. As, as more components and charging sources are added to a PV system, complexity increases. PV hybrid systems are considerably more complex than non-hybrid standalone systems. This means the more time the money need to go into this means that more time and money needs to go into the design and installation process. With additional components and more complex wiring, there are additional costs associated with the purchase, installation, maintenance of the system. There are many applications for PV hybrid systems. They are most often found in remote or off-grid locations, powering homes or cabins, or as a power source system for remote telecommunication or other electrical equipment. PV hybrid system can also be grid connected as well as shown later in this presentation. So that's what we say the PV and wind hybrid system. So this is a hybrid system here. You have many sources. You have the wind turbine providing you electricity to help charge your battery. You have what they call the wind controller, the wind controller with dumb load. So this is here, wind wind turbine, charge, send it into the wind. It's like a charge controller. Goes into your battery as well. You also have the PV system power supplying your home, also charging your battery as well. You're gonna need a battery-based inverter for that. So that's what they're saying. Now take into consideration here, you don't have a utility grid. Utility. You have other sources or multiple sources. You have multiple sources of charging. Wind turbine are additional power source that can be used with hybrid standalone PV system. My cover. Many people chooses PV wind hybrid system because wind and solar sources often complement each other. On calm sunny day, the PV array may be inadequate to maintain the battery. During the winter, windstorms or cloudy days, or in the evening, it is more likely that the wind source will pick up and wind turbine can be used to meet the load and battery charging demand when the PV falls short. So that's what they show you. So places like Sport, for example, we have a system we're trying to put on. We have a wind turbine on days that are cloudy days. The wind blows the fan, the motor runs, provide electricity. Electricity goes in there and also charges the battery. At the same time, we'll be able to help provide electricity or pick up the load for the home as well. That's what they're showing here. So we have the grid direct. Next, let's get the grid involved. The most common type of PV system configuration is the grid direct system. This system does not have battery or charge controller, nor the associated maintenance and cost that goes along with that. But it does require the grid to be present to function. This course focus on the battery-based system, not grid direct system. It is important to be clear on the distinctions. In the grid direct system, energy goes straight from the PV array into the inverter, which changes the DC electricity into AC electricity. This AC electricity then flows into an AC series panel, AC load center or breaker panel. operate active load. Any extra energy is pushed out onto the utility grid. When the amount of energy being produced by the PV system is less than the total AC load, the electricity from the grid comes into the home to make up the difference. When the PV system is not producing anything, such as light, then the house act as if there were no PV system at all the electricity coming from the utility grid. So that is what it's called a grid system. The disadvantage of this is that if on a rainy day there is no current from the utility grid, and you have no charges from your PV system, you're not going to have no current at all because you have no backup. You have no battery bank to store electricity. Let's talk about this. The system types. Typical net metering. Traditional net metering means excess energy produced by a grid direct PV system and not consumed by load. A critic is credited towards the bill at the same retail rate as energy is purchased. This right here does not really apply much to like grill because we don't sell electricity back to the grill. It's just saying that if your load is all handled in a day, excess current goes into the grill, go back to the utility grill company and lower your rate. So that means that if you're paying $100 for bill for electricity a month, you start paying maybe mm, $50 or $40 or $30, depending on how much electricity is being so or going to the grill. That's what it's saying. So that would call electrical metering. So that's what this is all about. SSPV energy exported to the grill. That's what this is saying. This not much of a system learning objectives. Okay. DC couple motor move system. This is important. The motor move system is both grill interactive and has energy storage. It can function as grill interactive or standalone. So motor move is very important, very complex as well. You have your PV system, you have the utility grill, and then you have battery. So you know the difference between this and a standalone system. Standalone system, you don't have the utility grill. Grill direct system, you have the PV array, you have the utility grill, but you don't have a battery. Motor move system, you have the PV array, you have the battery, and then you have the utility grill. So this is a motor move system, which means you have multiple charging sources, or multiple provisions of electricity that comes to handle your load. PV array in the day when it's sunny provide electricity that goes into what your your backup AC load panel, and then you don't have the meters begin to read backward, selling to the electricity. In the night, when there is no current, your battery begin to supply your home. As the battery get lower, your utility bill kick in, provide electricity for your home. That's what this is saying. You can use your battery to supply your home, and you can also use a utility bill to supply your home. That's what it's saying. What you notice here is that you can also use the current from the grill multi-move inverter charger to charge your battery as well. So that's a multi-move system. Very complex, very expensive system. Multi-move system. That's what it's showing here. The PV array to your grid direct inverter, grid direct inverter to your backup AC load, AC load to your multi-move inverter, multi-move inverter back the battery banks, the AC panel, and go into the socket, the wall socket in your house to provide current. You also have your meters here. The meter reads current going into here. It's a lot of complication there, but it's a beautiful system and it costs a lot of money to set up. So you guys in Liberia, maybe they'll set up this kind of system. Let me see. So this is exactly what. So this is it. about your redirect system. Just went through this. The DC coupled multi-mode systems. This is what we're talking about right here. DC coupled multi-move system configurations. Just explaining. Now, DC and DC and or AC multi-mode system. This is another one. There's another complex one right here. All-in-one energy storage system (ESSS) includes enclosure. Enclosures are beginning to become more common, much like a refrigerator. These come in a pre-wiring enclosure and are meant to be easy and safe to install and operate. So they are system now called the all-in-one enclosure. So they has this thing called the solar generator. What it does is that it's a box that has you have a PV array. Obviously, you have to install the PV array over your home or put it somewhere where you can get the sun ray true south, most preferable. You have your PV, you have this box that have inverter in it, you have battery in there, and you have a charge controller. So you take this box, you put it in your home, and then your PV array over your home. So now this connects directly to your all-in-one panel, which connects one wire going to your AC service panel or your backup AC load panel. So that is one of the recent system that just been developed that is being used. Somebody was telling me about very important system. Somebody was telling about that setup. So that's this is this junction. I'm going to say thank you for taking your time out here. Thank you for being a part of this course. Okay. At this junction here, we have time for questions and answer. It's very important that you, as you're doing this course, take a pen and write down some questions you have. It's good to listen. Um, you learn more by listening when this training is being shown or conducted. You listen very well so that you can learn and understand your training. I'm very excited. And I bless God that Mr. Puma is there um, facilitating this project, this training while you guys are on the ground. Any questions, I will be answering any questions also. I just want to say God bless. Thank you guys. Stay tuned for more training.